Off the coast of São Paulo, Brazil, 33 kilometers from the mainland, lies a small rocky island. From above, it appears as nothing more than a patch of green lush rainforest clinging to stone, surrounded by the endless Atlantic. But approach too closely, and you'll discover why no one is allowed to set foot here. This is Ilha da Queimada Grande. The locals call it Snake Island. Here, in just 43 hectares of land, as many as 4,000 golden lancehead vipers hunt, breed, and rule. Scientists estimate densities reaching 1 to 5 snakes per square meter in certain areas, some of the highest concentrations of venomous serpents anywhere on Earth. Their venom can kill a bird in seconds, a human in under an hour. The Brazilian Navy has sealed this island from the public. Only researchers with special permits may land, and even they must bring doctors. What created this serpent kingdom? What makes it so deadly? And what secrets does it hold that could one day save human lives? Welcome to the hidden world of Snake Island, where evolution, isolation, and venom converge. Snake Island sits roughly 33 kilometers off the coast of São Paulo State, a speck in the vast Atlantic. The island spans only 43 hectares, about the size of 50 American football fields. Its terrain rises from sea level to 206 meters at its highest point, a landscape of extremes. Bare volcanic rock, open grassland, and a quarter-square kilometer of dense Atlantic rainforest. The climate here mirrors the neighboring mainland temperate, with temperatures ranging from 18 degrees Celsius in August to 27 in March. Rain falls heaviest in December, lightest in July. Everything about this island seems ordinary. Everything except its history. 11,000 years ago, as the last ice age released its grip on the planet, massive ice sheets melted. Sea levels rose by 60 meters. Coastlines shifted. And this small outcrop of land, once connected to Brazil, became an island. The animals that lived here suddenly found themselves cut off from the mainland. No way forward. No way back. Among those trapped, a population of venomous pit vipers. For most creatures, isolation means death. But for these snakes, it meant opportunity. An evolutionary experiment had begun, one that would transform them into something found nowhere else on Earth. When the waters rose and the islands separated, the snakes faced a crisis. They had no predators, no jaguars, no raptors, nothing to keep their numbers in check. They could reproduce freely, but there was a problem. They also had no prey. The mammals that once scurried across the forest floor were gone. No rodents, no opossums. The ground was empty. If the snakes were to survive, they would have to adapt. They would have to hunt what came to them. And what came to them were birds. Every year, migrating seabirds crossed the Atlantic, stopping at this island to rest during their long journeys. For the trapped vipers, these birds became everything: food, survival, the key to their future. But birds present a unique challenge. Strike too slowly, inject too little venom, and your prey simply flies away. You starve, so the snakes evolved. Over thousands of generations, their venom became more potent, up to 5 times stronger than their mainland cousins, fast-acting, devastating. A bird bitten by a golden lancehead dies before it can escape. They also adapted their hunting strategy. Some climbed into the trees, waiting in ambush among the branches. Others developed what scientists call caudal luring, wiggling their tails to mimic prey, drawing curious birds within striking distance. This is evolution in real time, sculpted by geography, driven by hunger, a species remade by isolation. Meet Bothrops insularis, the golden lancehead. This snake exists nowhere else in the world. Adults grow between 70 and 118 centimeters in length, though some reach even larger sizes. Their bodies are pale golden brown, overlaid with darker triangular and quadrangular markings along their backs, patterns that shift and blend into the island as undergrowth. Their heads are triangular, lance-shaped, the feature that gives them their name. The head lacks the distinctive eye stripes of their mainland relatives. Instead, they have yellow-gold eyes with elliptical pupils that give them an unblinking, watchful appearance. But it's what lies within those lance-shaped heads that truly sets them apart. Like all pit vipers, the golden lancehead possesses specialized heat-sensing organs pits located between its eyes and nostrils. These remarkable structures allow the snake to detect the thermal signatures of warm-blooded prey. In total darkness, a golden lancehead can strike with pinpoint accuracy, guided solely by the infrared radiation emanating from a bird's body. The snake sees in heat. It sees what we cannot, and when it strikes, it does so with devastating efficiency. The golden lancehead's venom is hemotoxic, one of the most potent in the genus Bothrops. It attacks the circulatory system at a molecular level. Within seconds of injection, red blood cells begin to rupture. Blood vessels collapse. The venom contains enzymes that prevent blood from clotting, causing rapid internal hemorrhaging. Victims experience immediate pain and swelling at the bite site, followed by nausea, vomiting, and blood blisters. Then comes the bleeding from the nose, the gums, and the urine. Internal organs begin to fail. Brain hemorrhaging can occur. And the necrosis, the tissue death, is so severe that flesh literally begins to break down. Chemical analysis reveals something astonishing. The venom of Bothrops insularis is 5 times more potent than that of its closest mainland relative, Bothrops jararaca. It's the fastest-acting venom in the entire genus. Why? Because on Snake Island, speed is survival. A bird injected with this venom dies before it can take flight. There is no escape. Scientists who have studied human envenomation by related lancehead species report a 7% fatality rate without treatment. Even with immediate medical intervention, the mortality rate remains around 3%. Death can occur in under an hour. No confirmed human fatality from a golden lancehead bite has been officially recorded, but that's largely because humans aren't allowed near them. The Brazilian Navy doesn't take chances. Access to the island is strictly controlled. When researchers do visit, they wear protective boots, shin guards, and thick clothing. They move slowly, deliberately, scanning every surface before they step. And they always bring certified doctors equipped with antivenom and emergency medical equipment. Population estimates vary. Early sensational reports suggested hundreds of thousands of snakes, painting a picture of an island carpeted in serpents. But more rigorous studies have revised those numbers dramatically. The most reliable research places the population between 2,000 and 4,000 individuals, concentrated almost entirely in the island's rainforest areas. Still, in the densest zones, densities can reach 1 to 5 snakes per square meter. You could encounter a viper every few steps. This isn't sensationalism. This is Snake Island. Despite its reputation as a serpent kingdom, Snake Island supports a surprisingly diverse ecosystem. 41 bird species have been recorded here. Insects thrive in the undergrowth. Lizards scurry among the rocks. Millipedes, spiders, and countless invertebrates fill ecological niches throughout the island's terrain. Life persists. But the golden lanceheads are not generalist hunters. They are specialists evolved for a very specific prey type. Of all those bird species documented on the island, the vipers prey primarily on just 2. The Chilean Ilenia, which arrives each spring during its migration across South America, and the pale-breasted thrush, which visits in autumn. These birds use the island as a critical resting stop during their exhausting ocean crossings. They land, seeking shelter and rest. They have no idea what awaits them. The snakes have perfected their hunting strategy. Golden lanceheads are facultatively arboreal. They can hunt both on the ground and in trees, though they show a clear preference for the canopy when pursuing prey. Unlike their mainland cousins, who hunt ground-dwelling mammals, these vipers have evolved longer tails, an adaptation that helps them maneuver through branches with stealth and precision. In the trees, coiled motionless among the leaves, they wait. Their heat-sensing pits scan the environment, detecting the warmth of approaching birds. When an exhausted migrant lands nearby, the snake strikes. Fast, accurate, deadly. But here's what makes the golden lancehead's hunting behavior truly remarkable. Unlike most venomous snakes, which strike, release, and then track their wounded prey using chemical cues, the golden lancehead holds on. Once it bites, it doesn't let go. It keeps the bird clamped in its jaws until the venom takes effect and the prey stops struggling entirely. Why this unusual behavior? Because chemical tracking doesn't work in trees. A bitten bird that flies away before dying is lost forever, falling somewhere unreachable, in the forest canopy or tumbling into the ocean. The snake evolved to never take that chance. The venom's extreme potency ensures the bird dies within seconds, before it can even attempt escape. This is adaptation perfected by thousands of generations of trial and error. Interestingly, two resident bird species, the southern house wren and the bananaquit nest on the island, year-round yet rarely fall prey to the vipers. These birds appear to have learned the danger. They've evolved their own behavioral adaptations. Where they nest, when they move, how they approach potential danger zones. Evolution works both ways, predator and prey locked in an endless dance. Beyond birds, the snakes occasionally consume lizards and invertebrates, particularly when young. But as they mature, they become increasingly specialized bird hunters, their entire physiology tuned to this singular purpose. The island also hosts a complex web of smaller predators and prey. Millipedes march through the leaf litter. Spiders spin webs among the Maria Ficera shrubs. Insects pollinate the island's flowering plants. All of these creatures contribute to an ecosystem far richer than its small size would suggest. Yet compared to the dominance of the golden lancehead population, all other species remain secondary players. The island's story is fundamentally the story of its apex predator, serpent so perfectly adapted to its environment that it has reshaped the entire ecosystem around itself. But this success is fragile. The entire species depends on this one small island. No other population exists anywhere in the world. If something were to go wrong here, disease outbreak, catastrophic weather, habitat destruction, climate change, the golden lancehead would vanish forever. And that's exactly what conservationists fear is beginning to happen. Humans have always been drawn to dangerous places. We explore, we conquer, we tell stories. And Snake Island has generated some of the most chilling tales in Brazil. In the early 20th century, someone attempted to clear the island's vegetation by fire, hoping to establish a banana plantation. The burn was so extensive, it gave the island its Portuguese name, Queimada Grande, the island of the Great Fire. The plantation failed. The snakes remained. In 1909, a lighthouse was constructed to warn passing ships. A lighthouse keeper and his family moved to the island, isolated, alone. According to local legend, they didn't last long. The story goes that one night, snakes slithered through the windows of their home, attacking the family as they slept. They tried to flee into the forest, but there was no escape. They were found days later, dead from multiple bites. Another tale tells of a fisherman who landed on the island searching for bananas. Days later, his boat was discovered drifting offshore. Inside, his body lay in a pool of blood, covered in bite marks. These stories circulate in the coastal towns near the island. They're repeated, embellished, passed down through generations. Are they true? No one knows. What is documented is that the lighthouse was automated in 1920, and no one has lived on Snake Island since. Today, the Brazilian Navy enforces a strict ban. Only authorized researchers may visit, and they must follow rigorous safety protocols. The ban exists for two reasons: to protect humans from the snakes, and to protect the snakes from humans. Snake Island is not just dangerous, it's irreplaceable. The golden lancehead is classified as critically endangered by the International Union for Conservation of Nature. Its entire global population lives on this one tiny island. Over the past 15 years, some estimates suggest the population has declined by nearly 50%. The threats are numerous. Habitat degradation from vegetation clearing by the Navy during lighthouse maintenance, potential disease outbreaks, and most insidiously, biopsy illegal poaching by smugglers who capture the snakes to sell on the black market. A single golden lancehead can fetch between $10,000 and $30,000. For some, that price is worth the risk of almost certain death. To combat these threats, the island was designated an area of relevant ecological interest in 1985 under Brazilian conservation law. The Navy restricts all civilian access. Scientific expeditions require approval from the Chico Mendes Institute for Biodiversity Conservation, Brazil's federal conservation authority. Even then, visits are rare, brief, and carefully monitored. Researchers who do gain access must submit detailed proposals months in advance. They must demonstrate that their work justifies the disturbance. They must carry emergency medical equipment. And they must move through the island with extreme caution, knowing that one mistake could be fatal. This protection isn't about fear alone. It's about preserving a living laboratory, a place where evolution continues to unfold, where genetic isolation produces unique adaptations, and where science has barely scratched the surface of understanding. Snake Island offers scientists a window into evolutionary biology that few places can match. Here, a single species has adapted in isolation for 11,000 years, developing traits found nowhere else on Earth. Herpetologists study the golden lancehead's behavior, reproduction, and genetics. Because the population is so isolated, they face what biologists call a genetic bottleneck limited genetic diversity that can make a species vulnerable to disease and environmental change. Yet somehow, the golden lanceheads persist. Understanding how they maintain viability despite this bottleneck could inform conservation efforts for other endangered species. But perhaps the most promising research focuses on their venom. The same toxins that make these snakes deadly also hold potential medical applications. Compounds isolated from lancehead venom have already revolutionized medicine. Captopril, one of the first ACE inhibitors used to treat high blood pressure, was developed from toxins found in related Bothrop species. Today, over 40 million people worldwide take captopril or its derivatives. Researchers at Brazil's Instituto Butantan, the country's largest producer of antivenoms, are investigating whether golden lancehead venom contains compounds that could treat blood clotting disorders, cardiovascular disease, or even cancer. Some studies suggest the venom includes peptides with antibacterial and anti-inflammatory properties. Others point to molecules that might inhibit cancer cell growth. Each scientific expedition to Snake Island is high stakes. Researchers must balance the need for data collection capturing snakes, extracting venom samples, observing behavior with the risk of snakebite. One wrong step, one moment of inattention, and a life-saving mission could become a life-threatening emergency. But the scientists continue, because the potential is too great to ignore, because this island holds secrets that could change medicine, because sometimes the deadliest creatures on Earth are also the most valuable. Snake Island is more than a curiosity. It's more than a cautionary tale. It's a monument to the power of evolution, a reminder of how isolation can shape life in extraordinary ways. Here, cut off from the world, a species transformed itself. It adapted to impossible circumstances. It became faster, deadlier, more specialized. It survived when survival seemed impossible. And now, it faces a different kind of threat. Not from predators or starvation, but from the very species studying it. Human activity, even well-intentioned, poses risks. Climate change could alter the island's ecosystem. Rising sea levels might one day reclaim the land that isolation created. The future of the golden Lancehead hangs in a delicate balance. But there's hope. The Brazilian government's protection, though imperfect, has preserved this place. Researchers' work, though risky, has revealed its secrets. And perhaps most importantly, the world has chosen to respect this island, not to conquer it, not to tame it, but to let it remain wild. In an age when humanity dominates nearly every corner of the planet, Snake Island stands as a place we cannot control. We cannot visit freely. We cannot make it safe. And maybe that's exactly how it should be. This is a place where nature still makes the rules, where evolution continues its ancient work, where a single species, unique in all the world, clings to existence on 43 hectares of rock and rainforest. This is Snake Island, untouched, unforgiving, unbelievable. And it must remain so for the snakes, for science, and for the wild places that remind us we are not the only rulers of this earth.